This video tutorial I will explain using Java how to write a simple producer code which will send messages to the Kafka server which is deployed in Amazon EC2 instance. Here you can see Apache Kafka architecture. Here you can see the producer which will send messages to Kafka topic, and here you can see the consumer which will consume messages from Kafka topic. We will see how to write this producer code to send messages to Kafka topic. To create Kafka producer in Java, we have to follow 4 steps. First, we have to create producer properties. Then we have to create a producer. Then we have to create a producer record. Then we can send the data. We will see how to do that. Here you can see Amazon AWS console, and here you can see Amazon EC2 instance is running. Copy this IPv4 address, open Putty software, and log into Amazon EC2 instance. And we have successfully logged in. Then open WinSCP and log into Amazon EC2 instance. And we have successfully logged in. To access Kafka server publicly and send messages from producer which is outside of EC2 instance, we have to do some changes. What we have to do is we have to open server.properties file, and listeners we have to add like this, and the port number by default it is using 9092. Instead I have given 8082, and one more property called advertised listeners. In that we have to provide plain text colon, then the host name, then port number. Port number is 8082, and then we have to open security group of Amazon EC2 instance, and we have to enable 8082 so that this port can be accessed publicly. We will see how to do that. Open server.properties file, and here we have to provide the host name, and here you can see the host name. Copy this, save the changes, close it. Then click on security, click on this security group, click on edit inbound rules, click on add rule, - 8082, click on anywhere IPv4, save the changes, and here you can see the changes has been saved. Next, I am going to start the Zookeeper server using this command. Zookeeper has been started. Next, I am going to start the Kafka server using this command. And Kafka server has been started and it is using 8082 port. Next, I am going to create animal topic. For that, I am going to use this command. Copy this host name and give the proper host name. And here you can see animal topic has been created. Next, we will start the consumer which will listen on animal topic. Copy this command and we have started the consumer which is listening on animal topic. Here you can see Kafka Producer demo project and here you can see Kafka Producer demo Java file and here you can see the pom.xml file and here I have included the dependencies of Kafka clients and SL4J. Here I have defined the class Kafka Producer demo and inside main method I am creating Kafka Producer properties. Here I have created a properties object and in that I am setting bootstrap server config which is nothing but Kafka server host name and port number. We have to make sure this host name is equivalent to this one. Then I am setting key serializer class config and value serializer class config. Then I am creating a producer object using Kafka producer constructor and in Kafka producer constructor I am passing the properties object. Here I am calling get animal list method and this method will return list of animals. Here I got animal list. Using for each loop, I am getting each animal name and sending to Kafka topic. Here I am creating a producer record and in producer record constructor, I am passing topic name and animal name. Topic name is nothing but animal topic and once producer record is created, using send method of producer object, I am sending animal name to the Kafka topic. Then I am printing this information. Then before sending next record, I have put sleep for 4000 milliseconds. And in finally block, I am calling flush method of producer and close method of producer. Left side the producer Java code is there and right side the consumer is running. Now I am going to run this Java program and here you can see the producer is sending message and immediately the consumer is consuming the animal names. dog, lion, tiger, snake, and cat. And whatever messages are sent from producer, that has been consumed by the consumer. In the example we have seen, we have used three producer properties: bootstrap servers, key serializer, and value serializer. To create Kafka producer, we need to create the object of Kafka producer. And in order to send data to Kafka, we need to create producer record. And in producer record constructor, we have to specify the topic name and the message value. And in this case, key is assumed to be null. And using send method of producer object, we can send data to the Kafka. The data produced by producer is asynchronous. Therefore, we need two additional methods, which are flush and close. These methods are required to ensure the producer is shut down after the message is sent to the Kafka. The flush method will force all the data that was in send method to be produced, and the close method stops the producer. If these methods are not executed, the data will be never sent to the Kafka, because main Java thread will exit before data are flushed. This video tutorial I will explain how to write a consumer which will consume messages from Kafka server, which is installed in Amazon EC2 instance. Here you can see Apache Kafka architecture. Here you can see the producer which will send messages to Kafka topic. Here you can see the consumer which will consume messages from Kafka topic. In this example, Kafka server is installed in Amazon EC2 instance. We will see how to write consumer code which will consume messages from Kafka topic. To create Kafka consumer in Java, first we have to create consumer properties, then we have to create consumer, then we have to subscribe the consumer to specific topic, then we have to create a for loop to receive the data. We will see how to do that. Here you can see Kafka consumer demo project, and it has Kafka consumer demo.java file, and here you can see pom.xml file, and in pom.xml I have included the dependency of Kafka clients and SL4J. Here I have defined the class Kafka consumer demo. Here I have defined the topic name as animal topic. Inside main method, here I have declared bootstrap servers, which is Kafka server IP address and port number, and group ID as group 99. And here I am creating consumer config. Here I have declared properties object, and in properties I am setting bootstrap server config, which is Kafka server IP address and port number, and key deserializer class config, and value deserializer class config, and group ID config as group 99, and auto offset reset config I have set as earliest. And here I am creating a consumer object, and in Kafka consumer constructor I am passing the properties object. And this piece of code is needed to make sure consumer is shut down gracefully. Here I am calling subscribe method of consumer object to subscribe consumer to the animal topic. And this piece of code is used to pull the new data from Kafka topic. Here I am calling poll method of consumer object and passing duration. This method returns consumer records and using for each loop I am getting each consumer record from consumer records. Then I am printing key of consumer record and value of consumer record, and also the consumer record is coming from which partition and what is the offset, and this details I am printing, and in finally block I am calling close method of consumer object. Here you can see Amazon AWS console, and here you can see the EC2 instance is running. Copy this IPv4 address, open Putty software, and it is successfully connected to Amazon EC2 instance. Open WinSCP, and it is successfully connected to Amazon EC2 instance. The Kafka server is installed in Amazon EC2 instance. To make sure the Kafka server is accessible from outside world, we have to do some changes. First, we have to open server.properties file, and in listeners, we have to give like this. Default port is 9092. Instead, I am using 8082. And in advertised listener, here we have to give the EC2 instance host name. Then we have to provide the port number 8082. And we have to open a security group. In that, we have to enable 8082 port so that we can access Kafka server from outside world. Open server.properties file, and here you can see listeners. I am using 8082 port, and here we have to provide EC2 instance host name. Here you can see the EC2 instance host name. Copy that. Then save the changes. Click on security. Click on this. And here you can see already I have enabled 8082 port. The same configuration you have to do so that 8082 port will be accessible from outside world. Now I am going to start the zookeeper server. Use this command. Next I am going to start Kafka server. And here you can see the Kafka server is started in 8082 port, and here you can see the host name. Copy this host name. Next, I am going to create animal topic, and animal topic has been created. And here I have created three partitions for animal topic. Copy this host name, and here you can see the consumer program, and here we have provided localhost. Instead, paste the host name, and also change the port number to 8082, and run the consumer application. And consumer application is successfully running, and it is listening for any messages in the animal topic. Now I am going to send messages to the animal topic, and for that use this command. We have to use producer console. Left side producer is there, and right side consumer application is running. I am sending animal name as lion, and here you can see it consumed the value lion immediately, and it is from partition 0 and offset 0. And here you can see the value cat is consumed, and it is from partition 0 offset 1. And here you can see the value tiger is consumed from partition 0 and offset 2. And value eagle is consumed from partition 0 and offset 3. And value cow is consumed from partition 0 and offset 4. Similar to producer properties, Apache Kafka offers various different properties for creating consumer as well. And to know more about each consumer property, visit this link. Here I have opened the link, and here you can see the consumer configuration supported by Apache Kafka. Here you can see each property and their corresponding description: key deserializer, value deserializer, bootstrap servers, group ID, etc. Key deserializer. It is a deserializer class for the key, and which is used to implement deserializer interface. Value deserializer. It is a deserializer class for value, and it is used to implement deserializer interface. Bootstrap servers. It is a list of host and port pairs, and that are used to establish an initial connection with the Kafka cluster. Group ID is the unique string that identifies the consumer group this consumer belongs to. Auto offset reset. This property is required when no initial offset is present, or if current offset does not exist anymore on the server. And these are the possible values we can use. And these are some essential properties that is required to implement a consumer. In our consumer program, auto offset reset value we have set it as earliest, which means on the first run of the application we will be reading all the historical data from the topic, which is animal topic. And here we are creating a consumer object to leverage the properties we have set. And to read messages from the topic, first we need to connect the consumer to the specific topic or subscribe the consumer to the specific topic. And for that we are using subscribe method of consumer, and here we are providing list of topic name. In this case we are connecting to only one topic, so we have given only animal topic name. And suppose if you have to connect to multiple topic, then here we can give list of comma separated topics. Consumer reads data from Kafka through polling method, and this poll method returns the data that hasn't been fetched yet by the consumer, which is subscribed to the particular topic. And here we are passing the duration. The duration is the amount of time to block on this call before returning empty list in case of no data was returned. In the consumer program, we have assigned group ID of group 99 to the consumer. So the consumer belongs to the group 99. We will stop the consumer application and rerun the application. And you will notice there are no messages displayed in the console. This is because the Kafka keeps track of consumer reads, which is nothing but consumer groups offset, and therefore the consumer will not encounter the same messages twice. And if we change the group ID to group 100, then consumer belongs to the new group, which is 100, and then run the application, then you will see all the messages in the console, because the consumer belongs to the new group, and it will read all the historical data from topic, and it will display in the console. Stop the consumer application, and I am running this consumer application again, and this time the historical data are not coming because it is the same group. Now I am changing to different group, group 100. Stop this, save the changes, and run the application. And this time we got all the historical messages from animal topic because it is different group. Stop this application, and if I run again with the same group, this time we won't get the historical data because it is the same group. Now we will see what is partition rebalance. Moving partition ownership from one consumer to another consumer is called rebalance. Rebalances are important because they provide consumer group with high availability and scalability. Currently, we have only one consumer in our consumer group. Therefore, the consumer reads from all the topic partitions. To see rebalances in action, we have to launch another consumer by running the same consumer application. We will see how to do that. When we create animal topic, we have created three partitions. So if only one consumer is there in the consumer group, then consumer will read data from all the three partitions. Suppose there are three consumers there in the consumer group, then each consumer will read from specific partition. For example, consumer 1 will read from partition 0, consumer 2 will read from partition 1, consumer 3 will read from partition 2. We will see that example. Already one consumer is running. I am going to start two more consumers. Start one more consumer and start one more consumer. Here you can see there are three consumers are running. This is first consumer log. This is second consumer log. You can see the PID is different. This is the third consumer log. Now I am going to post some more animal names. Now check first consumer log, and first consumer is consuming messages from partition 0. Check the second consumer log. The second consumer did not consume any messages. Check the third consumer log, and third consumer also did not consume any messages from animal topic, because all the messages are posted in partition 0, and only consumer 1 consumed all the messages from partition 0. So whatever we have seen, all the messages are posted to partition 0. To avoid that, we will send different keys. We will see how to do that. And before that, I will start three consumers. First consumer is started. Second consumer is started. And third consumer also started. Here you can see three consumer has been started. Now I am going to use this command, Kafka console producer topic name is animal topic, then bootstrap server host name and IP address, and here I have introduced one more thing, property parse key is true, and key separator is colon. Copy this command and key I am giving as 1 colon, then value as lion, key as 2, value as tiger, key as 3, value as cow, key as 1, value as crow, key as 2, and value as snake. Now check the consumer application logs. Here you can see first consumer log, and here we got key 1 value lion from partition 0 offset 23, and key 1 value crow from partition 0 and offset 24. Check the second consumer log. Here we got key 2 and value as tiger, and it is from partition 2 and offset 1, and key 3 value as cow, and from partition 2 offset 2, key 2 value as snake from partition 2 offset 3. Now we will provide some other key 5 and value as boar. We will check which consumer got that message. The consumer 1 got the message. Here in right side, consumer application is there. In left side, producer application is there. Now I am going to start consumer application. Consumer application has been started. I am clearing the log, and now I am going to start the producer application, which will send messages to animal topic. Here you can see producer is publishing messages to the animal topic, and here you can see the consumer application consuming messages from animal topic. Clear the log. Now I am going to run the producer application one more time, and here you can see the consumer application consuming messages from animal topic. You can get Java source code link for each video from the description section of the video. And here you can see the video, and to see the description, click on this more, and here you can see the description, and here you can see the links, and click on these links to get the Java source code.